Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the fifth lecture for the course of control system. This is the second part of the fifth lecture. My name is Engineer Jaffar Ali and I am instructor for this course. Let's start with the recapitulation of the first part of the fifth lecture. In the first part of the fifth lecture, we have discussed about the rotational mechanical system. We have introduced ourselves to rotational mechanical system, that what is rotational mechanical system, and we also learned about the analogy between a rotational mechanical system as compared to translational mechanical system, that how you can translate your translational mechanical system into rotational mechanical system using different variables and using different notations. So you have seen the analogy that how different variables that were involved in translational mechanical system have now changed into different other variables, that let's say mass has become inertia, and you see that this force has become torque, and the displacement has actually, the x of t has become angular displacement, that is a phi of t. This angle theta is basically phi of or you can say theta of t is now the angular displacement, which was a linear displacement in terms of translational mechanical system. We also did an example to find out the transfer function actually, that how you can calculate the transfer function in the first numerical. We saw that there was a system which whose input was a torque which you were giving to the system, and after that the motion of the body or the J2 was actually in the angular displacement phi of 2. So now you have to calculate the phi of 2 divided by t of s to find a transfer function. This was the transfer function mentioned over here. You can see that this was a transfer function that we found out using different mathematical operations, and what we did was we actually separated the different inertias J1 and J2, and we calculated the overall effect of both of these equations. And after we wrote down these equations, these two equations, we just found out the value of this phi 2, that is, and divided this phi 2 by this ts. So we found that the value of the transfer function comes out to be k by this delta, and this delta is nothing but the derivative of the matrix that we generated from these two equations. We have clearly displaced these two in the previous lecture, the first part of this lecture actually. So now coming towards today's class will be very much interesting, because we are going to look at some other example that involves some gears in it, and we have assumed that the gears is lossless, because in electrical system, I've already told you about the electrical system. Give me a moment to fix this keyboard pressing error. I'm getting this automatically key pressing error from due to some virus that is indulged in my computer. I don't know the reason yet. So this is your question that it has asked you to find a transfer function for a system that has involved some gear system in it. So let's start with the very basic previous knowledge of electrical system. In electrical systems, you have learned about the transformers, that how you can actually step up or step down any voltage that is provided to you using a help of a transformer. Same is the case with this gear system. You actually increase the RPM or speed or torque or angular displacement of a system as to an output of given if you are given with an input. So this is your same thing over here. And if you remember that in electrical system we all mostly consider losses in the transformer, but in this system, mechanical system, we are ignoring the mechanical losses that is provided or that is generated by this using of gears. So this is your example. You can see that there are two inertias that is connected with a gear N1 and a gear of N2. So in electrical system we talk about the turn ratio. So in mechanical system we talk about its gear ratio. This is N1 and this is N2. These are the teeth of that gears actually. So from that you can find out the gear ratio between J1 and J2, the rotation of J1 and J2, the angular displacement of J1 and J2, to be very specific. And if you convert this whole system, it has asked you actually let's start the question so that it will be much clear to you. It is mentioned to find out the phi 2 divided by T1 of S. It means that you have applied some torque over J1, and due to some this motion of this translation of this teeth, the motion is converted into this J2. I'm sorry guys, I cannot solve this problem right now. I have to look at this later on. So you have to actually transfer this mechanical portion of here N1 into N2 actually. So now if you want to transfer this, this is your phi 2. This is your phi 2, and you can see that this phi 2 is the rotation of J2 actually, and this J2 is connected further with a damper and some spring K2. You can see that this is K2, and this J1 is connected to a damper D1, and this is the given system to you, and it has asked you to find this thing, that rotation of this angular rotation or angular displacement of J2 divided by the input you provided on the J1, that was the torque. So if you divide your system into different components, you can see that this is your system. I have simplified this, and how we can solve this, let's see. So starting with writing the equation for the system 1, we have actually divided the system two parts. One is as a whole. So you can see that if you write down the equation, you can easily find the following equation using the same thing that we discussed earlier, that the total force applied on phi 2 is actually J1s square plus ds square plus ds plus ke is equal to T1 into N2 by N1, and this N2 by N1 is nothing but the gear ratio. So as you see in the electrical transformer about the turn ratio, here is it the gear ratio N2 by N1. So how do you find the value of this thing actually? Using we have reflected the impedance J1, J2 and T1 on the input shaft to the output shaft as shown in figure 2.3b. You can see that we have converted this whole system into this system, and this is very easy. You just have to incorporate all these. This JE is basically the combination of this J1 and J2. Similarly, this DE is the combination of this damper D2 and this D1 with some multiplication of their gear ratio. And similarly, there is only one K involved, so that is why you cannot see the K term with some multiplication of N1 by N2. So this is the thing that is mentioned over here. So now if you add these all these things, so you can see that the total GES square. So you can see that in this diagram, we are basically combining these two portions and writing it down to a single portion, or single, you can say, single diagram. And this is very easy to write down. You just have to take the turn ratio or the gear ratio into account, and the total inertia that will be becoming, you can see that the total or equivalent inertia for both of these will be as shown in the figure, in the equation over here, n2 divided by n1 whole square. Similarly, the total damping will be equal to d1 and 2 by n1 square plus d2. Similarly, this K isn't connected directly with the gears actually, so it is not mentioned with the N2 or N1 anything. This total, there is only one spring involved, that is K2, so it is wrote as it is. So now you have, if you write these things into a single equation, you get this equation that JES square plus DES plus KE into theta 2 of S is equal to T1 S multiplied by N2 by N1. So you see that this is the main equation that you got from this. And the question that you can ask is why you have reflected this square with n1 by n2 by n1 square with these things, and not square with these things. So this is from the table that we have discussed earlier. In the previous lecture we have discussed about the impedances. So this is basically the square of the impedance. So this is basically the square of the impedances. That is why it is mentioned as a square. Similarly, this torque is not a resistance; it is the source, so it is not mentioned with the square. So if you have wrote down this equation, it is now very easy for you to solve this thing, that is to find the value of theta 2 divided by ts. You just have to rearrange these terms, and if you rearrange these terms, you find the value of you can find the value of this thing, that is theta 2 divided by t1 of s. So this comes out to be n2 by n1 divided by JES square plus DES plus KE. So this is you know that this JE is actually nothing but J1 and 2 by n1 whole square plus J2. Similarly, this TE that is mentioned over here is nothing but D1 multiplied by the square of n2 divided by n1 plus D2, and this KE is just Q2, because you can see in the diagram there is this there is only one spring in the system, and that is connected to J2 and not with the gears. So that is why it is not multiplied by n2 by n1. And most of you may ask that why this is n2 by n1. So similarly, this is the case where you deal with the same concept of electrical transformers. You always if you find the turn ratio, you always divide the turns of output, the turns of secondary coil divided by the, you can see that turns of secondary divided by the turns of primary. So now it is very much clear to you. This is basically same here, but the variables are changed now. This has now become n2 divided by n1. So if you write this thing and you solve this thing, it will be much clear to you, inshallah. So this is your rotational mechanical system, where you involve these parameters and as a whole, not separately. You have combined this and you have found one equation. Instead of going towards two equations, you actually found the value of one equation, and by using this one equation you can easily find out the value of the transfer function, that is theta 2 of s divided by theta t1 of s, and this comes out to be this equation. So guys, you know that my keyboard is not properly working, so I have thought another way to explain this mechanical rotational mechanical system to you. Just hang on a bit. I will try to solve it on this paint actually. So let's take the diagram from here, and I will tell you how to solve here this problem. Over here you can see that I have to remove all of these unnecessary things. So let's get started. So the major thing that we actually want to do in the rotational mechanical system is the thing that we want to solve every system into a kind of system in which there is only one input, that is equivalent torque, and we apply by combining this J1 and J2 we actually find the value of the equivalent inertia, that is JE. Similarly, we also find the value of these are individual dampers, so we actually find the value of the combined damper in the system, and this combined damper will be termed as DE. Instead of D1 and D2 will be this DE. And similarly, we also find the value of KE, the equivalent spring that is attached with the wall. So this is the thing, if you are given with any rotational mechanical system, you have to find these parameters TE, DE, GE and KE, the equivalent of all these things, these terms. And how do you find the value of these terms? Using the formula that I have given already here. These are the formulas that you can see that these are the formulas. You can find the value of this TE, JE, KE, DE from these equations, and you can see that actually we have found out the value as well. For JE, you have to add multiply this J1 multiply with the square of the ratio of N2 and N1 with addition with J2. So if you want to solve it, you can easily find. As in also in future, if you are given with some system that has more gear system, let's say this is connected to a, instead of wall it is given to a gear. Let me tell you how. Instead of this wall, let's say there is a gear. Let's say this is a gear, and this gear is N2, N3, and further it is connected to another system of another same thing. Let's say the same thing over here is connected to this side as well. So now you will have to find three. This J1 will be first you have to find out the combination of these, and you will find this JE actually for these two systems. Then you will the answer from this JE will be combined with this as well. So this thing will go on and on unless and until you reach the final point. Let's say this is the final point and here is the wall. Let's say this is the wall over here. This is the wall. So you will end up here. But this JE will be different from this JE because in this diagram it was mentioned like something like this. So you will be finished over here. So the first step is that you have to find the equivalent variables that are involved in this term, and after you find out the equivalent variables, it is now very easy to solve because you have got the same rotational mechanical system in which you have some input in some direction and there are some outputs in another direction. So you do the same methodology that we discussed in the translational mechanical system, that I should write it down for you, that the, let's say this is your J, and you do all the same procedure, that the force is applied, the torque is applied on this direction, the damping was in this direction, the Ke was in this direction, the inertia was in this direction. So you add up these things to find the value of, you write the equation, and the equation for this systems turns out to be this thing. Let me tell you, this equation. The equation after you solve, sorry, see, you can see that the keyboard is still not working properly. uh, this is the equation that you found out. Like this, I have to crop this before pasting it out there. This equation, this is the equation that you can find out using this mechanism. So it will all obviously involve sub n2 and n1, because these parameters, that is JE, DE and K, is it involves n2 and n1. So after you find, the first thing is for you is to solve any rotational system. First you write down, I will repeat it again. The first step is that you have to write down the equivalent of all these variables and convert your big system into one system, that is something like this. And now you can easily find out the value or you can write down the equation for the system, and for using that equation you will be able, and the equation comes out to be this, and using that equation you can find the transfer function, that is, you can see that this is theta 2, this is theta 2, and if you divide this theta 2 by this t1, you get the value of the transfer function, and which is in this case is n2 divided by n1 divided by JES square plus DES plus KE. So this is the brief overview. I am sorry for the several problems of my keyboard. I'm going to save it for you as well, and I'm going to upload it within the video, so that you can pause the video and have a clear look over it. So it will be good for you if you do this practice, these equations by yourself. And I'm sorry guys for this keyboard error. I have trying to solve this problem since morning, but there is no solution that I can find till now. So maybe in the next class I might be able to solve this or fix it. So apologies for that. I suggest you to download the PDF with yourself and listen to the audio as compared to the PPT or PDF file that I have uploaded on the portal as well. So that's all for today. In the coming class, we will look about the electromechanical system. We will basically combine the electrical networks with some translational portion, and also with some DC motor, that is rotational portion. So in that electromechanical system, you will be seeing all of this mathematical modeling that we have learned in the previous 3 or 4 lectures, actually 4 lectures. So you will be learning about these 4 lectures in the next class as well, but that will be overall look of an electromechanical system. It will not be dealt separately. I will teach you how to solve electromechanical system, but I hope and I look forward that you will be able to learn quickly, because I have invested very much time to explain these topics individually. So in the next class we will be basically combining all of these topics, that is electrical systems, and it will involve RLC, and in mechanical system we will be seeing this. You can see that we will be seeing the translational mechanical system, which was discussed in the previous lecture in the last week, that is 4th week, and we will see that how this mass spring damper and a resistor, inductor and capacitor, and this spring, jumper and inertia combines to form an electromechanical system. And how you can find the transfer function of electromechanical system? Mostly in electromechanical, you can see, if you remember, in electrical system the output and input was both of the terms was in electrical quantities, that was current or voltage. In mechanical system, the output and input both are in mechanical terms, that is either the torque or the force or the movement or the inertia or the theta. So in electromechanical system, it is some kind of system in which the input is of one form, that is electrical or mechanical, and the output is of another form, that is mechanical or electrical, or vice versa. So if you are giving a current to a motor, so it will be producing some torque or angular displacement as a result of a DC motor. So that is basically electromechanical system, and we will look that how you can find the transfer function of that electromechanical system in the next week, that is week number 6. So prepare for that. I have also given you an assignment to solve 10 problems for electrical systems. Now the assignment for this week will be to solve 10 problems from mechanical systems as well, so that in the coming week, if you come with in the next week, so you will be able to solve electromechanical system with more efficiency, with more good performance, and I look forward to see that performance actually. So that's all for today. If you have any question regarding this question, we will discuss that inshallah class. I look forward to see you in the class. Please be on time and bring your assignment of the last week, that is kindly upload that assignment till today. That's all for today. Thank you very much. I'll see you in the class. Allah Hafiz.